All right, so today we're going to review multiplying fractions, and here we're going to include the mixed numbers, okay? So here it says the eyeball of an Atlantic squid is about 12 times as large as the average human eyeball. The average human eyeball is 1 1/4 inches across. We want to use this diagram right here to compare the average size of a human eyeball to the average size of an Atlantic squid's eyeball. Okay, so here we've got 1 1/4 inch, that's for the human eyeball, and this whole thing is going to represent the squid eyeball. So because it says up here that it's about 12 times as large, then we need to have how many spaces in this box here? We need to have 12 spaces in that box. And how big is each space going to be? 1 1/4 inch. Very good. So this is what that looks like. Right? Very good. So number 2 says, write a multiplication expression that shows the size of the the size of the Atlantic squid's eyeball. So here, when we are multiplying, oh, I skipped number 1. Number 1 is down here. We want to use this diagram to compare the average size of the Atlantic squid's eyeball to the average size of the human eyeball. And we want to use repeated addition, because you know repeated addition is multiplication. Very good. So here, that means that if I add up all of my whole numbers, let me use blue here. If I add up all of my whole numbers, what am I adding? 1 plus 1 plus 1 plus 1 all the way to 12. Very good. So if we add the whole numbers, I'm just going to write whole numbers. There's going to be 12 there, right? Now, if I add the fraction parts, all right, F for fraction, we've got 1/4 plus 1/4 plus 1/4. How many 1/4 am I adding? 12. So that's going to be 12 fourths. And 12 fourths, of course, is equal to 3 wholes. Very good. So that means that we've got 12 inches here and 3 inches there. And what do I do to get my final answer? You just add them together. Very good. So we've got 12 plus 3. So that tells me that how big is that squid's eyeball? 15 inches. Very good. Number 2 says write a multiplication expression that shows the size of the Atlantic squid's eyeball. So here, if we were adding 1 1/4 plus 1 1/4 plus 1 1/4 all the way to 12 times, that would be 1 1/4, just like she said, times 12. Very good. So 1 1/4 times 12. Now, we want to write this multiplication equation using improper fractions. So you guys remember how to make improper fractions? We're just going to, let's review that. We're going to go this way. And what do I do in that direction? 4 times 1, right? And then what do I do in this direction? Very good. Plus 1. So this is going to be, and what can I do with this 12? I can put it over 1. Very good. I can go ahead and put that over 1. So down here, I've got 12 over 1 times, what's my improper fraction going to be? 5 fourths. Very good. So we have 12 over 1 times 5 fourths. And of course, if they asked you to multiply this, we would multiply straight across. Is everybody clear with that? Is there something that I can do before I multiply straight across to make this an easier problem? Good. We could simplify before we multiply. And you can see that with the 12 and the 4, they have a common factor that we can divide out, right? So 4 divided by 4 is 1, and 12 divided by 4 is 3. So now, when we multiply straight across, we end up with 3 times 5, which is 15, over 1 times 1, which is 1, which just gives us 15 inches. All right, so here we're going to multiply a fraction and a mixed number. It says here to multiply a fraction and a mixed number, first write the mixed number as an improper fraction. Remember that when the mixed numbers are written as improper fractions, the denominator does not change. Then we're going to multiply as with fractions. So this here is what I'm going to highlight what I want you to write down. So for example 1, it says find 1/3 times 1 3/4, and we want to write it in simplest form. All right, so here we have 1/3 times 1 3/4. Remember, you don't have to write this example down in your notes, okay? We're just going to talk about it. So when we're multiplying fractions and mixed numbers, what you're going to do is you're going to, if there are mixed numbers, you're going to change them to improper fractions. So 4 times 1 is 4, plus 3 is 7, and that gives me 7/4. So I have 1/4 times 7/4, and then you want to check to see if you can simplify before you multiply. You always check to see if you can simplify before you multiply. If you can, do it. Here, we can't, right? So now you're just going to multiply straight across. So you have 1 times 7 is 7. And 3 times 4 is 12, so our final answer is 7/12. Piece of cake? All right, very good. So, on the next example, we've got 5 1/2 times 1/3. So once again, now you guys, there's a lot of blanks in here that you're not going to have to fill in, okay? So I'm going to show you down here when we do these examples together how I want to show you work, okay? So here we have 5 1/2. When we multiply 5 and 1, when we change that to an improper fraction, we have 5 times 2 is 10 plus 1. That's going to give me 11. And then again, the denominator stays the same. So that's 11/2. That's going to be multiplied times 1/3. Here, once again, we can't simplify anything, right? So we're just going to multiply straight across. So 11 times 1 is 11, and 2 times 3 is 6. And now you have an improper fraction. So now you want to change that improper fraction back to a mixed number. Very good. So how many times does 6 go into 11? 1 time. With how many left over? 5. So this is going to be 1 and 5. And what's my denominator going to be? 6. So this is 1 and 5/6. So now we've got the got it problems, and these are the ones that I want you to write down in your notes. Okay, so you're going to write, you can write example 1 and 2 or example A and B, any way you want to label it. Just make sure you know that those are the examples. All right, so for example A, for the first got it, we've got 2/3 times 2 1/2. Okay, the first thing we want to do is we want to change all of our mixed numbers to improper fractions. So we've got 2/3 times, the improper fraction here will be 2 times 2 is 4, plus 1. That's going to give us 5/2. Very good. So we end up with 2/3 times 5/2. Now, before we multiply, we will simplify. So can I simplify? Yes, we can. Very good. So the 2 and the 2, we can factor out a 2, right? So 2 divided by 2 is 1 down there. And 2 divided by 2 is 1 up there. And now we're going to multiply straight across. So 1 times 5 is 5. And 3 times 1 is 3. And now we're going to change that back to a mixed number. Very good. So 3 goes into 5 how many times? Once. With how many left over? 2. So that's the numerator, and the denominator, good, stays the same. All right, so when we multiply 3/8 times 3 1/3, we end up with 1 1/4. Very good. All right, now we're going to multiply mixed numbers. So to multiply two mixed numbers, we're going to write each mixed number as an improper fraction, and then we're going to use the GCF, or the greatest common factor, to simplify. So here, what I want you to write down is to multiply two mixed numbers. You're going to write each mixed number as an improper fraction. And don't forget to write your topic title up there too. So you're going to multiply mixed numbers. All right, so for example 3 here we have find 1 7/8 times 3 1/3. And we want to write that in simplest form. Now, just like it says up here, we want to change all of our mixed numbers to improper fractions. So 1 7/8 changes to 15/8, good, times 3 1/3, which is 10/3. Now, once again, before we multiply, we are going to simplify, and that's what they did here in red. So, with the 8 and the 10, the GCF between those two is 2. So we divided 2 out of both of them. So 8 divided by 2 is 4, and 10 divided by 2 is 5. And then with the 15 and the 3, the GCF is 3. So we're going to divide a 3 into 15 and 3. So 3 divided by 3 is 1, and 15 divided by 3 is 5. And then we'll just multiply straight across. So 5 times 5 is 25, and 4 times 1 is 4. And then we'll change that improper fraction back to a mixed number. All right, now with the word problem here, it says the Hoover Dam contains 4 1/2 million cubic yards of concrete. The Grand Coulee Dam in Washington State contains 2 2/3 times as much concrete. So that means that we're going to multiply how much the Hoover Dam is. We're going to multiply that times 2 2/3 times that much. Does that make sense? So here we wrote our problem. We changed the mixed numbers to improper fractions. We simplified before we multiplied. We multiplied straight across. And we ended up with 12 over 1, which is 12. So there are 12 million cubic yards of concrete in the Grand Coulee Dam. All right, so here, let's do this got it problem. It says here, Mr. Wilkins is laying bricks to make a rectangular patio. The area he is covering with bricks is 15.5 feet by 9 3/4 feet. What is the area of the patio? So the first thing we need to know here is the formula for the area of a rectangular patio. You're going to write, so we need to know that the formula for the area of that rectangle is length times width. And as a matter of fact, I'm going to write area is equal to length, and I'm not going to use the x, I'm going to use the dot, times width. The reason I don't want to use the x for multiplication is because the x looks like a variable, right? So length times width. So that is the formula for the area of a rectangle. So now you're going to write down other important information. So what is the length going to be? All right, so you're going to write length is equal to 15 feet. This is the length. And the width is equal to 9 3/4. So that is the important information that you're going to write in your notebook so you don't have to write down the entire problem, right? Now, the question that they ask us is what, whoops, that's too dark. What is the area of the patio? So you want to write down the question that you're answering. What is the area of the patio? So now that we have all of our important information, now we can start filling in. So the length is, good, 15.5 feet, times the width, which is, good, 9 3/4 feet. And now what do I have to do to those mixed numbers? Change them to improper fractions. Very good. So we have 15 times 2 is 30, plus 1 is 31. So this is going to be 31 halves, right? Times 9 times 4 is 36, plus 3 is 39. So this is going to be 39/4. All right, so since we cannot simplify anything here, there's no GCFs in any of these numbers, we're going to just have to multiply straight across, okay? So when you multiply straight across, and you did your work on your scratch paper, I just showed you, 31 times 39 is equal to what? What did you get? 1,209. Very good. 1,209. And then we're going to multiply 2 times 4 is piece of cake, right? So now you're going to show your long division, okay? So I'll show you that in my notebook. So I just showed you on the notebook how to do the long division. And when we did that division, 1,209 divided by 8, how many times does 8 go in there evenly? 151. And how many did we have left over? We had remainder 1, so that 1 becomes the numerator, becomes a fraction part, and the denominator stays the same. Very good. Now we need to make sure that we label it, because this is a word problem, right? So this is 151 and 1/8. What are my units going to be? And because this is area, this is going to be feet squared. So feet squared. You know, with the little exponent up there? Help you become